Hello again, ladies and gentlemen. This is 2.14 Quadratic Relations, and I will be using the mouse for a lot of this. There's a few sections where I actually need to use the pen. So this is still review, and this should be a little bit more fresh in your minds because we did do Quadratic Relations towards the end of the first cycle. Unfortunately, I don't believe we're going to get to a third cycle, but this should be a good jumping off point regardless. Okay. 2.14 Quadratic Relations. Activity would be to practice number 1 and 2 to start. Since we can't take it up together, I'm just going to dive into the lesson. So a quadratic relation can be represented 3 different ways: standard form, vertex form, and factored form. In that same order, that's our standard form, which only gives us our a value, our step pattern, and our y-intercept. The vertex form, which gives us the vertex, so it does give us our step pattern as well, because that's the a value. Then our step pattern is h and k. For this, I would actually write it as, oh, my pen's off. Ready to go. Perfect. A x minus h squared plus k. I don't like the plus. Just because it makes it a little bit more complicated when you're trying to figure out what your vertex is. So your vertex for the top is actually just h and k. But if you use the bottom formula, your vertex is minus h and k. And oftentimes I've found in university and later courses, teachers tend to use the top equation more than the bottom one. So I would highly recommend using the top equation there. Finally, we have our factored formula. This is fine the way it is. Sometimes you'll see x minus p, x minus q instead. As long as you know that whatever sets that bracket to equal 0 will give you your p values. I guess the same would be said for the vertex form. Whatever gives you 0 in the brackets will be the x value of your vertex. So if you have x plus 8, then negative 8 for x is going to be where your vertex is, because negative 8 plus 8 gives you 0. All right, that's enough on that. We already know these. Oh, just going to hide that. Non-linear. So non-linear means a parabola. You're going to see more of these in later grades, more non-linear relations. But for grade 10, we only deal with parabolas and linear equations. The highest exponent is 2. It has to be equal to 2, the highest exponent. If the highest exponent is greater than 2, then it's not a parabola, it's a different shape. If it's less than 2, then it's a line. Your first difference is different, but your second difference is a constant. That just means when you take the difference of your first difference, it's going to be the same each time. Your vertex is your maximum or minimum point of the graph. The graph is symmetrical about the axis of symmetry. Sometimes I use a shorthand, which is just A, lowercase o, and then S, AOS. Some teachers do this, others don't. Just be careful in later grades because they might dock marks for that. I personally wouldn't. Points to follow the step pattern are a times the odd numbers, so 1, 3, 5, 7, and then a times those numbers. It opens up if a is positive or greater than 0. If a is equal to 0, then it's not a parabola. And it opens down if a is negative or less than 0. And a is the same across all different representations of quadratic relations. The y-intercept is the c value of our standard form, and that's pretty much all the information we get from that. Now, you can pause this and copy it down. I'm going to move on to the next slide. First example here. This is actually a true story. So, to keep young Carl Friedrich Gauss, some pronounce it Gauss or Gauss, is a German name. Busy in primary school, or elementary school as we call it here. His teacher gave him a task of adding integers from 1 to 100. He astonished her by coming up with an answer very quickly by discovering a formula. We're going to complete this table of the sum of the integers from 1 to x and see if you can come up with a formula and graph it. Well, 1 plus itself, or plus nothing's before 1, so it's 1. Then 2 plus 1 is 3. Then 3 plus 2 should be, 3 plus 2 plus 1 is 6. Then 4 plus 3 plus 2, so 4 plus 6, which is our last answer here, should be 10. 5 plus 10, 15. 6 plus 15, 21. Okay, now we can take our first difference. Difference between 1 and 3 is 2. Difference between 3 and 6 is 3. Difference between 6 and 10 is 4. So on and so forth. We start to see our first difference here. It is different, but now we take our second difference between 2 and 3. It's 1. Oh, for some reason it's up this time. Difference between 4 and 3 is 1, 1, 1, 1, 1, 1, 1. And we see that pretty clearly. Now we can graph this. I'm going to plot the points and then I'm going to reveal it. So 1, 1 is our first point here in red. 2, 3, so 2, 3. 4, or 3, 6. And then 4, 10. And then 5, 15, which is up here. And then 6, 21. Okay. Now I'm going to reveal this. This should look a little familiar. Of course, it's off by a little bit, and if I move it at all, I'm going to mess up where the dots are. So the screen capture was off just by a little bit. Our formula, well, take a guess at what the formula is. I'll give you a second to think about it. You can pause the video and think about it. And I'm going to reveal it in 3, 2, 1. There we go. So the formula is actually n times n plus 1 divided by 2. So now you can figure out the sum from 1 to 100 by subbing in 100 for n. So 100 times 100 plus 1, so 100 times 101 divided by 2 is equal to 5,050. So this is a quadratic formula method to solve this. This is a true story. Gauss was able to do this from my fact checking. Another way he thought about it was if you have the numbers 1 plus 2 plus 3, so on and so forth, all the way to plus 98 plus 99 plus 100, he would match the outermost. So you had 1 plus 100, then 2 plus 99, and then 3 plus 98. And he figured out that it's just 50 sets. 50 sets of these that add up to 101. And when you multiply it out, you actually get 5,050. So that's another way to think about it. Of course, we want you to think of the quadratic method. This is number theory. So if you're ever interested in diving into that, Gauss is really popular in number theory. He is a very prominent mathematician, so I would recommend reading into that if you have some spare time this summer and you're interested in learning about the history of math. But I digress. That is a little bit off topic. Let's kind of dive back into the next slide. Okay, this slide's a little awkward because I didn't feel like cutting it up was going to help. So I have this graph. Justin is standing on a cliff. It's 16 feet high. He throws a stone in the air, and it follows the path shown in the graph. The vertex. Well, we need to determine what the vertex is. If we look very carefully, we see that it is at 3 seconds. The horizontal difference is 3 feet, and it is 25 feet high because it's halfway between 24, and 26. So it should be 325. What does it represent? Well, when it's traveled 3 feet, it should be 25 feet high. So the stone reaches maximum height of 25 feet when it's 3 feet from the cliff. Perfect, because he threw it from the cliff here. The y-intercept, well, it's 16 feet, and that represents where the stone was thrown from, or the height of the cliff. The 0 is where it hits the ground. We would say 8 feet from the cliff. So it's 8 feet from the cliff. The axis of symmetry, we're going to add that to the graph here. I'm just going to do a dashed line, and it would continue upwards. And that is going to be x equals 3, because 3 is the x value of our vertex up here. So we know x equals 3. Use the axis of symmetry to find the other 0 on the graph. If you guys recall, when we did our assignment, there was a question very similar to this. It was a thinking question, where if you drew the axis of symmetry, it was pretty clear where the other 0 was going to be, and then you could then figure out a formula and work your way backwards. This is basically that question, except I'm explaining it to you a little bit clearer without you guys having to do problem solving on your own. So, from 8 to 3, we went back 5, and then we have to go back another 5, so it should be -2 will be our other 0 here. Right there. -2, perfect, because from 8 to 3 is -5, so we -5 again, because our axis of symmetry, it's symmetrical on either side of the symmetry, axis of symmetry. That means that it's going to be 5 units left again to find our other 0. Find the equation of the graph in factored form. Well, we don't know the a value, but we can do this. We know it's going to be negative, whatever the a value is. We can just verify the step pattern back here. Our first step is over 1, down 1, over 1, down 3, over 1, down 5, and so on and so forth. So we can see the step pattern. Luckily for this, we're given a pretty nice graph to solve. However, I can't guarantee that that's always going to be the case. In some cases, you'll actually have to sub in your y-intercept. So you'll set your y value, or your h value in this case, to equal 16 and your x values to equal 0, and then solve for a. In this case, it's -1. We were lucky that it was pretty straightforward. It could be a fraction. You should never assume, given a graph, if you are given 3 points, you should be able to solve. Okay. So determine the equation of the graph in standard form. In order to do this, you're going to expand. And whenever I say expand, you should be thinking FOIL. So first, outside, inside, last. I'm going to change my pen over to blue. So first, outside, inside, and last. So x times x gives us x squared. So in our standard form, we should have -x squared. I forgot about the negative. Negative is going to be multiplied in. So I'm going to do a step over here, x squared, and then plus 2x, or minus 8x first, plus 2x, because you do your outside, then your inside, and then you do your last, which is 2 times -8, which is -16. Then we would collect like terms and then multiply in the a value. Minus 6x minus 16. All right, now we can multiply in the negative value. So you get -x plus 6x plus 16. Perfect. Oops. All right, I'm going to move on to the next slide, just a heads up. In 3, 2, 1. All right. Example 3, our last example for this lesson. Choose the equation you think is the best representation of this graph. I'm going to get my notes out just because I want to make sure that I cover everything you need to explain. So I'm just going to verbally explain how to do this and how you know which one's correct and which one's not. First, let's take a look at example A. The zeros for A are -6 and -2. So we know A is not one of them because the zeros are wrong. However, the zeros for B are 6 and 2. So yes, B is 1. I'll put a check mark next to it too. C, well, let's take a look at C. The y-intercept that's given, because we look at the C value right here. So the y-intercept in standard form is -12 here. However, it's up here. So that doesn't work. So C is incorrect. Okay, what about D? Well, if we look at the y-intercept, it's +12. That's checking out all right. However, if we expand B, we actually get the E value, or the E equation here. So this is expanded B. That means using FOIL, x times x gave us x squared, -6x for, or -2x minus 6x, and then plus 12. So -6x minus 2x would have given us -8x, not plus 8x. So that doesn't work. Okay, that's it for that lesson. All the best. You guys should be able to work through the practice work on this. Always review your lessons or your notes. If you need to go back and review some lessons from Cycle 1, that's okay. I will link the YouTube channel for you within this week or next week, I believe. So then you can go back and check it without going through Edpuzzle and that player. All right. Best of luck. And if you have any questions, post them on the forum.